Today we are going to discuss how the data is to be presented. You know that in planning as well as in statistics, data plays a very important role in all our work, and on the basis of this data we are going to make a plan. And previous classes we also done what are the different type of data and what are the different types of variable which are attached to those data by which the data is identifiable. But again, just a small revision. We have done the variables of two types: categorical type variable or numerical variable. And numerical variable we have divided into form of discrete and continuous. And similarly, to measure that variable, and that is the form of a data, that we classify into two categories: qualitative and quantitative. And you are very well aware of that, what is a qualitative data and what is quantitative data. And quantitative data, again we are divided two categories: interval and ratio, and qualitative data in the form of nominal and ordinal data. So accordingly, now the data is in front of us. So now we are going to learn how to present it so that the decision can be done. So we know that descriptive statistics is nothing but organizing, summarizing and presenting the data in a very easy form so that the decision maker can take a decision, that people can draw conclusion from that, and the data should be presented in such a manner that it would become easy for them to conclude or to use it purposefully. So presenting the data, there are different methods of presenting the data: tabular presentation, diagrammatic form, graphical form or numerical methods. So presenting data in this format is known as data presentations. Now first of all we talk of tabular presentation. Now in tabular presentation, the whole data we used to group on the basis of some specified value of a characteristics, that is on which we are measuring the data, and the number of time data is appearing for that particular value of characteristics is presented in the form of rows and columns, and it is called tabular presentation. But how to do this classification? First of all, whenever we have to present the data in tabular format, we have to classify the data. So classification of data is nothing but is arranging the data according to some common characteristics into mutually exclusive classes. Mind it, mutually exclusive classes. That is, whatsoever the classes we are making it, the data should appear only one and only one class, not in more than one class. So what are the merits of classification? Why we require to do the classification for presenting the data in tabular format is, classification helps in condensing the data, makes our job very easy to compare the data, and relationship between different criteria is very easy to understand after doing the classification. And from the classification we can go for the further statistical or advanced statistical analysis. So that makes our job very simple. Now what are the rules for classification? The first rule is, there should not be any ambiguity in the classes. It should be defined clearly, specifically and stable. It is not that in one shot we are using one class and another we are using another classification. It is not. Classes should be exhaustive and mutually exclusive. That is, data is appearing in one class should not be the part of another class. That is the most important. Now basis of classification, we can classify the data on these four categories. The first one is geographical or area wise or regional wise classification, or chronological, that is on the basis of time we can classify the data. Then qualitative, that is on the basis of characteristics or attribute. This we are normally using for qualitative data. Some attribute we are taking, on that basis we are making the classification. And quantitative, on the basis of numerical value of magnitude. So whatsoever the numerical value we are having it, that we are dividing into groups, and then on the basis of we are doing the classifications. Let's see one by one. First of all, the geographical basis. So in this we are classifying the data on the basis of location, country, state, cities, regions, zone or area wise. So anything which we are presenting with respect to country wise, state wise, city wise, region wise, zone wise, area wise is known as geographical way of presenting the data or geographical basis. So simple example is population of India in different cities in 1961. This is old data. Mumbai is leading. Mumbai, Kolkata, Delhi, Chennai, Hyderabad and Bengaluru, and source is Census of India. So but one thing we should take care of that. Normally we are presenting data either in a alphabetic order or in the magnitude of the value. Just see here in this case we are presenting the data on the basis of magnitude of the value. That is the highest value we are given the top priority. We are not going alphabetic A, B, C, D. So it is A, B, C, D, then it should be Bangalore should come first, but we are doing the population wise, the highest wise. So if we are doing the lowest one, the Bangalore is again number one. So that is the fundamental way of presenting the geographical basis. Then chronological basis, that is on the basis of time. So it is a time series data which you are presenting it. Now here we are showing that production of a company in tons in different years is being given. 1960, 1970, 1980, 1990, 1998. So this they publish in the company handbook 1999. So it shows that the production is increasing. Now you can draw a conclusion that is within this number of years, production of this company is continuously increasing. So this is the one conclusion which you have drawn from this table. Mind it, this is not the last one. This is the beginning of drawing the conclusion. There are number of other you can say attributes are also there which need to be seen. In this when normally we are presenting the data in ascending order with respect to time. We have to follow certain rules also. So in geographical, again we are going again either is a ascending order, descending order, but here it is with respect to time in ascending order. Now qualitative base. Now qualitative base, here the data is we are using the qualitative characteristics. So either we can present with respect to attributes, so it is known as cross table or contingency table. And if we are having only two classes, male or female, now third gender is also coming, that third gender is also there. So if we are only two, there is a yes or no. So it is known as simple or dichotomous classification. Let's see. Number of employees in ABC company, 35 males and 26 females. Transgenders, they are not taking it. This is their company. Source is company handbook. Now if classification we are doing more than two classes, so then it is known as manifold classifications. Number of employees in ABC company, the same company, in male skilled and unskilled, 20 skilled, 15 unskilled, female 5 skilled and 20 unskilled, and total is 60. Actually this male should come, heading is this line should not be there. So this line should not be there. So female should be licked and male should be there. So it is from the company's handbook 1999. So this is our on the basis of time chronological data. On the basis of qualitative base. On the basis of qualitative, now we can the same data, just see here the qualitative phenomena which you are presenting, skill or unskill or male or gender. So if I present it in this manner, female, male, skilled or unskilled, so what is wrong in that? So this is nothing but my contingency table or cross table. So this table looks much better, and here anybody can draw conclusion very easily in comparison to previous table. So this is the art of tabular presentation. Now quantitative classification. In quantitative classification, we are using certain data, we are presenting the basis of certain phenomena, that is which is measurable, like weight, height, temperature, expenditure, distance, etc. Now the phenomena which is under study, which we are measuring it, is known as a variable that we had done previously. and number of times a variable is occurring, that is a data which is attached to that variable, is known as frequency. So number of times that variable is occurring is a frequency. So the organizing the data in the form of variable and frequency is called frequency distributions. So the quantitative data when we are presenting in tabular format is nothing but we can also say it is a frequency distribution. And you know that variables are of two types, discrete variable and continuous variable. So accordingly we can also divide into that. So that phenomena we can also take it here. So there are different types of presenting the data, this quantitative data. First of all is unorganized data or organized data. Now let's say that we have just collect the data of 50 households, the size of the households. So 2, 5, 3, 6 like, so there are 10 values, so not 10 values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yes. So we are and 5 values here, so there are 50 data values. So this we are inputting in unorganized manner, they are not organized. So this data is known as raw data or unorganized data. But this data, it is very difficult to conclude any information from this. And if data is very big, this is only 50 households. If there are 500 households, you cannot draw any conclusion from that. You cannot listen the voice, what the data is saying. Now the next stage is organizing the data or arrange the data. Either you arrange the data in ascending order or you arrange the data in descending order. It makes some sense. So now we have organized it. So just see 1, 1, 2, 2, 3, 3, 4, 5, 5, 6. So now in organized data, I can simply say that is a 3. It is occurring maximum number of times, that is 9 times it is occurring. But and the rest 4 and 5 both are occurring 6 times. So what is the variable? Household size. And what are the frequencies? That is household size 5 is 6. What is the frequencies? Household size 4 is 6. What is the frequencies? Household size is 3, frequencies 9. But if data is big enough, still this organized or arranged data is not going to help us. We have to divide form of frequency distribution. So the first one is the discrete frequency distribution. We know that discrete variable and continuous variable. So in this format again it is an ungrouped discrete frequency distribution, we can take it. So in this method data is presented with respect to specific value of a variable. That is all possible value of a variable is listed in the left hand column, and then using tally bar system the frequency are written in the front of the variable value. Let's see how it is. Now family size, the same problem which you had taken, the same problem. Now tally size we have written family size 1 to 15. So again we draw the tally bar from there, and then the frequencies, the 3, this is 5, this is 5 plus 4 9, this is 5 plus 1 6, 5 plus 1 6, 4 4 5 2 2 2 2 2 2. Now we have developed our first ungrouped discrete frequency distribution. Now something it makes a sense. Now we can easily say, now somebody asks what is the family size, how many families are there where the family size is 10, so you can say only 2 families. But there is no families which have a size 11 or size 13 or size 14. So something you can draw from here. But just think, if it is the value is very big, in place of 15, in place of family size something else is there, it is 100, then becomes very difficult to use this ungrouped method. Then we have to go for the group frequency distribution. So ungrouped method, which we are doing it, we are doing the discrete value also. So in a group frequency distribution, here the variable is divided into stable number of groups, and these groups are called classes or class interval, and then data we are putting into these different classes. depending upon its value. Let's see. Now we make a group family size 1 to 4, 5 to 8, 9 to 12 and 13 to 16. We are trying to make equal size. This group should be equal size. So now with the tally bar we go on putting the data. So in the family size 1 to 4 there are 23 households. From 5 to 8 there are 19 households. From 9 to 12 there are 6 households. From 13 to 16 there are 2 households. So now it makes some sense. So we can say immediately that if I have to plan a housing colony, so maximum demand or maximum family size people fall in the category of 1 to 4 or 5 to 8. And 9 to 12 or 30 to 16 they are less. So I won't bother about that because I have to sell my product. So now this table is guiding me, telling me that how can I take a decision. This was a discrete one. Mind it, this is discrete one. Now here we are now condensed data, and the length of class interval it is 3. What is that? 1 to 4, 4 minus 1, 3, 8 minus 5, 3, 12 minus 9, 3, 16 minus 13, 3. That's why in place of 15 we have written 16. And this 3 is called width or class width or magnitude of the class. And the values of class are known as class limit. Higher value is upper limit and smaller value is known as lower class limit. And just see. So this 4, 8, 12 and 16 are higher class limit, and 1, 5, 9, 13 is known as lower class limits. Next we come to the continuous frequency distribution. Now in a continuous frequency distribution, normally it is a continuous variable, but nobody has stopped us to use a discrete variable also into continuous frequency distribution. How it can be done, that we'll discuss. So here in discrete frequency distribution we have just seen the class width, that we have to have the constant class width, the same class width we should have. The same principle is here, but here the classes are made A, that is lower class limit, B is upper class limit, A is less than equal to data value and it is less than B. So just see, let's take the example of age as a variable and number of children as a frequency in this question. So what we say? We say 0 to 3, that is anything which is equal to 0 and above 0 will come under this category, but less than 3. If it is equal to 3, it will come into this category. If it is equal to 6, it will come into this category. If it is equal to 9, it will come into this category. And equal to 12 is out of question, that will not come. So we have to make a class interval in such a way that your whole data will be presented. So the lower limit includes the value and upper limit excludes the value. So that value is not included in this value. So we can say there's any child whose age is 3 years, there are only 3. So we can put it the values and we can put the data in this manner. Now what are the principles of designing group frequency distribution? Number 1, there is no fixed rules how many classes we should meet. It is up to your problem. It is up to your study. But on the basis of your study, on the basis of facts, which value or characteristic or comparison is meaningful, you have to make that classes accordingly. You cannot make a classes that age you are making classes, you cannot make that age is more than 150 years or 1000 years. So that class is meaningless. So number of classes should not be too large or should not be too less. If there is any specific reason, then try to maintain those classes that are used in our previous study, so that it is a comparison, it is very easy to do the comparison. So normally we are making 4 classes to 20 classes. We try that number of classes should not go more than 20. And for our convenience, it is better that the number of classes should be multiple of 5. So it makes our, you can say, further statistical analysis more easy. Now, how to design, what are the principles for designing the group frequency distribution. So the width of the class, for convenience, we always use equal width class interval. It is easy. But in some time we can require unequal class widths also. But how to do that, that we'll see. So width of the class is, how to design the width of the class? Range, maximum value, largest value minus smallest value, divided by number of classes. How many classes you want to make? 10, 5, 15, like this. So try to make class widths in such a way that midpoint we can fix a midpoint easily. That's what, if it is a multiple of 5, then the midpoint will always be your integer number. You can draw, and from that midpoint you can draw further conclusions. So this is a principle of designing the width of the class. Now there are three types of class interval: inclusive class interval, exclusive class interval, and open-end class interval. This inclusive class interval are nothing but what your discrete type class interval. So 2 to 6, we know that nothing will be there between 6 and 7. 7 to 11, nothing will be there, 11 and 12. So 16 and 17, nothing will be there, 16 and 7. So it is a type of a discrete type of class interval. So it is known as inclusive class interval. So in which upper limit and lower limit are the part of this class interval. But in exclusive, mostly used for continuous frequency distribution. Here the upper class limit is not part of this class. 10 is not the class of this class interval, 15 is not the part of this class interval, 20 is not the part of this class interval. This is a difference between inclusive and exclusive. So here we can say all the values we have taken, 10.0000, 10.15, 10.35, they all will fall in this category. Even 10 will also fall in this category. 10 will not fall here in this category. The maximum value will be 9.999999999. That will fall in this category. But above than that will not come in this category, which is 10. Then open-end class, where the lower limit of the first class and the upper limit of the last class is not defined. So it is an open-end class. So it is a very rare occasion. Sometimes some problems, some attributes are like this, that for us we can't define the lower limit and upper limit. But try to make the other class intervals equally spaced, equal width. Other class interval should be equally width. Now coming to the cumulative frequency distribution. Now cumulative frequency distribution is telling us how many values are less than or more than a specified value of a variable. That is just in the previous example I can say that is how many families are having the family size less than 10. So you can simply club those two class intervals. So similarly, the cumulative frequency distribution, we have two types: less than cumulative frequency distribution and more than cumulative frequency. So less than cumulative frequency tells us the total number of values less than a given specified value of a variable. So it is constructed by combining the frequencies of all preceding classes including up to that classes. And more than cumulative frequency is reverse of this. So it is opposite of less than cumulative frequency. So it is constructed by combining the frequencies of following classes including up to that class. Reverse. Let's see. Now variable is given. Variable ranges class with 0 to 5, 5 to 10, and frequency is given. So less than cumulative frequency 4. In this 4, this 5 is added, 5 plus 4 plus 5, 9. And now in 9, this 10 is added, 10, 19. Now in the 19, 8 will be added, 27. In 27, 6 is added, 26, 33. So this must be same. So it can be written less than 0, nothing is there. Less than 5, 4 values are there. Less than 10, 9 values are there. Less than 15, 19 values are there. Less than 20, 27 values are there. Less than 25, 33 values are there. And similarly, more than cumulative frequency, we start from the bottom. So we start from the bottom, 6, then 6 plus 8, 14, then 14 plus 10, 24, plus 24 plus 5, 29, plus 29 plus 5, 33. So we write more than 0, everybody, 33. More than 5, 29. More than 10, 24. More than 15, 14. More than 26 and more than 25, nobody, 0. So this is how the cumulative frequency table we can create. Now come to the table. Tabulation is nothing but it is a frequency distribution which we are presenting is nothing but a table. So in table we can say a little bit more classify that it is a logical presentation of our quantitative data in the rows and columns. So in tabulation data we are presenting in the condensed form through which we can draw a conclusion. So your frequency distribution is nothing but your table. So what are the rules for a table? What are the components of a table? So every table, number one, must have the table number, bind it. Your now reviews are going to start. You are going to do now site planning, and after that you are going to do ODP. You are going to show your data in the tabular format, that is the frequency distribution, but your jury member will fire you if these things are missing. First of all, table number. If you are presenting more than one table, then you must have a table number. It is very necessary for giving the references. And how the table number is to be given? If you are writing in a chapterization process, so chapter 1.1, 1.2, 1.3 and say with chapter 2.1, 2.3 or 2.4. If you are not in the form of chapter, you are presenting the sheet form. So environmental aspect, E1, E2, E3, E4, transport concept, transport network concept, TN1, TN2, TN3, housing concept, H1, H2, H3. So I can immediately say that H means housing, T means transport, E means environment or land use, L1, L2, L3 related. So that's how we can give the table number. Each table must have self-explanatory, brief and concise title. It should come at the top of the table. Without title, your table has no meaning. And if necessary, you can give the head note for more clarity if it is needed. Then caption and stubs. The heading of columns is known as caption and heading of the rows are known as studs. So you have a proper self-explanatory captions and stubs. So one can understand what is that. Now you have just seen that we have done the variable and frequency family size. So we must have the proper caption and stubs. Then the body of table, that is we are presenting the table form. That footnote, if necessary, that some figure which is coming there which requires certain explanation, so you can present it by putting at the star, double star, hash, this type of symbol on that data, and the bottom of the table you can give a footnote. This star data present this double star data present this, or hash presented this. And finally you must have a source note, that is from where you are taken it. You are taken primary survey, secondary data from book or from other sources. You have seen in my presentation I used to give disclaimer also. It is not my work, taken from somewhere else, from Google, from everywhere. So I am giving that from which source I have collected this material which I am presenting to you. That is very important. So component tables, one has to take care of that very carefully. Like this is the format. So captions, that is the column heads. Stubs, that is our row heads. So format of the good table, table 1.1, demonstration only, total, grand total and source were written. So this way you present the table. Next come to diagrammatic and graphical presentation. You know that although tabular presentation provides the data in condensed and clear form, but everybody knows that the data is presented in the form of diagram, in the form of picture. Then it will give immediately the attention will be there. The listener, your jury member, or to whom you are presenting your work, he will immediately understand what you are saying. That is the power of diagrams. So in comparison to tabular presentation, diagram and graphs gives more attention and people understand very easily what you are saying. So these are two form, diagrams and graphs. Now both are difference. There is a difference between the two. What is the difference between the two, diagram and graph? Diagrams are prepared on a plain paper and graph is prepared on graph paper. Mind it. Diagram cannot be used for studying the relationship between the variables, but in graph we can. How? That will I will show you in further slides. In diagram, it can be constructed by bar, square, circle, etc. But graph constructed of lines and points. Diagram gives approximate information, but graph gives accurate information, complete. Diagram normally we are using for categorical or geographical or ungrouped data, and while the time series data, frequency distribution or group data we use to present in the graphical form. So diagram provides approximate information and graph gives precise and accurate information. So this is a difference between the two presentations. So construction of diagram, it must be neat, it should be clean with proper lettering. Letter must be written very clearly, and you can use different colors, different shades also depending upon your liking. That's how the architect students are much better in position to present their drawing sheets in comparison to other disciplines. Again, diagram, I am not biased, but it is my experience, because 5 years they are only rubbing with the pencil and rubber, etc. and the color. Yes, planners are, B planner are also equally capable of doing that, but if I just compare the people coming from geography, statistics or operations research or economics background, so they have to learn these techniques, how to make a better diagram. So each diagram must have a diagram number, title, footnotes, if it is required then you should give, or source note. And title must be self-explanatory, and diagram number has the same rule as a tabular presentation, that it should be a unique number. And source is very important. Scale, height and width of the diagram. Actually there is no fixed rules, but the selected scale should take care of proper size and size of observation, which you are going to present it, what you are, here time is too short. Actually this my lecture is of 6 hours, but I have cut it into 2 hours. So then I should have shown you how to present in diagrammatical format in excellent manners. If number of diagrams are more than that, then all should be presented in same scale. It should not be in the different scale we should use it. So, but there is no fixed rule of proportion, but guiding principle is we use the ratio of 1:2 between small size and large size respectively, normally, but it is not the thumb. Index. Each diagram must have an index describing about the shade, color, lines, etc. Now you have very well experienced in your area appreciation exercise. Everybody is asking where is the index. Now type of diagram. One dimensional, which is consisting of a line and bar diagram. Two dimensional, which is rectangular, square, circle or pie diagram. Three dimensional, cube, sphere, prism, cylinder and block diagram. Pictograms and cartograms. Let's see one by one what are those. Now bar diagram, there is one dimension. For qualitative category normally we are using it. For business or economic data is more stable for presenting by bar diagram. One must understand which diagram is best way to present which type of data. So here we are, it is constructed in the form of vertical or horizontal bars of equal width drawn on a, if it is a vertical bar then it should be a horizontal line, if it is a horizontal bar then it should be on vertical line, which is known as a baseline. So on a baseline we are drawing this bar. The height of bar is proportional to value of a variable, and bar should have a uniform spacing between them, and proper coloring or shading you want, you can give it so that bar can be distinguished very well. And the values or magnitude may be written on the top of the bar. It is always advisable, so no person will ask that what is the value of this bar, what this value of bar present. Now type of bar diagram, simple bar diagram, subdivided or component bar diagram, percentage bar diagram, multiple bar diagrams, deviation bar diagrams or broken bar diagrams. One by one we will do it. Now the first one we are taking that population of different towns in India. Karanpur, Gatsinghpur, Suratgarh, Lohar, Anupgarh, I don't know which this city belongs to which state. Source Census of India 1981. This is not my data, my dear friends. I am only presenting my students' data. You are showing it in your studio. So I have taken from that, or you are doing thesis under me. So I have taken the data that I am presenting, using it in my class. So bar diagram, just say population. This is our baseline. So all the bars are equal distances normally. So erect the bar. So put the value 5,000, 10,000, 15,000, 20,000 and 35,000 maximum values. So we put it. So in bar diagram, immediately anybody can find out what is the population of different cities. Now subdivided or component bar diagram. Now here is a little bit tricky. So the question is given the average expenditure. Mind it, this exercise you are going to do in ODP. Average expenditure per month of household in a given town is in a given town in various years is given. Food, education, housing, transportation, others. And year 1990, 91, 92, 93 and 94. I want to see that their expenditure has increased or not. If the expenditure has increased, so in which field it is being increased. That is the I want to draw a conclusion. In which area the people are now spending more money. So in different years. So in the 5 years, how the changes are coming in that particular town. So first of all, for each year 1990, 91, 92, 93, 94 should be written like this. And then the expenditure, food, education, housing, others. So now we draw the cumulative values. 1,200 plus 500 is 1,700 and 1,700 plus 700, 2,400, 200 added 2,600 and 2,700. So this is the cumulative values for 1991. Similarly, cumulative values, this is CV, is not CU, CV. See, the computer is also very smart. I used to try it V times U. So 1,500, 550 we join, 2,050. Now 700 is added, 2,750. Now 250 is added, 3,000 and here 70 is added, 3,070. Similarly, we draw the cumulative values for 1992, cumulative value for 1993 and cumulative values for 1994. And this cumulative values we are presenting like this. Just see. For 1990, 1,200, 1,700, 2,400. So up to 1,200. So next value cumulative value is coming, then next value cumulative value is coming, next value cumulative value is coming and next value cumulative values are coming. So that's what I have make index, food, education, housing, transportation and others. And expenditure this at different years. So just see, I can very easily conclude, very easily, that the expenditure and almost on the most of the aspect they are increasing, but on the food, it increase on the great rate. Food expenditure difference is more. Then your education is increased, housing almost same, transportation little bit increase, and others little bit expenditure. So as the year passes, the expenditure pattern of the families of that area, that town is described like this. Now this table gives us this presentation. Through this you can explain very easily. Now percentage bar diagram. Here now we are putting the cumulative value. The same thing we can do it by using the percentage. Now the trip purposes, the trip distribution purpose wise in percentage is given to us in a given town. Trip purpose, work, mind it, this is ODP exercise which we are going to do after your site planning. Work, education, shopping, others and total. So in developed urban areas, what is the percentage of trip on work? 44%, education 22%, shopping 15%, other 19%, total is 100 of a particular town. We are doing the particular town. So its cumulative value we have taken it. So cumulative percentage 44, 66, 81 and then 100. Similarly, undeveloped urban area, then fringe area, then periphery area. So for all of this we have taken it and then taking the cumulative. For undeveloped area, this is a percentage of work trip is 46, percentage of education trip 29, percentage of shopping is 17, and percentage of other trips is 14. Yes, I am very happy. There is undeveloped urban area having more work trip, and education trip is again more, shopping is again more. It is a good. I am happy to see their number of trips are more. So I am computing the cumulative trips. And the fringe area, yes, fringe area is more, further more. So we are taking the cumulative values here. So periphery area, again we are taking the cumulative values. Now this cumulative values we will draw. This cumulative value will draw it. Just see the percentage bar diagram. So percentages we are drawing it. And previously bar diagram, component bar diagram, we are talking the absolute values. And here we are talking of percentages. So here very easily, which percentage is moving how? We can easily see like this. So this we can say that percentage bar diagram is showing in a much better way in comparison to component bar diagram. So I can, in comparison, I can compare very easily. Now multiple bar diagram. Now traffic volumes at outer cordons of a given city, incoming and outgoing. Cordon point 1, 2, 3, 4, number of vehicles. Simply you have to draw bar diagram. Cordon point 1, cordon point 2, cordon point 3, cordon point 4. So incoming is this color, outgoing is this color, like this. So present the data, number of vehicles, present this way. So here I can comparison each cordon, that in which cordon, which traffic direction is more, incoming is more or outgoing is more. So here I can use this type of diagram to present my data. Now coming to deviation bar diagram. Now this deviation bar diagram we are using to present those variables which are having positive and negative values. What are those examples? Profit and loss, surplus and deficit. So that we can present in the form of deviation bar diagram. So the positive values are present in the bar in the form of a bar on the above a baseline, and negative values below the baseline. So you can say it is a biasness. So positive value is above the baseline and negative value is below the baseline, only to encourage that from negativeness you come back to positiveness. So the data is percentage decadal variation of urban population of class 5 cities of India is given. Now that we are going to show it. In decadal growth, class 5 cities, 19012 to minus 4.23 plus minus 51 to 61, big loss. 61 to 71, again negative. 71 to 81, we increase. 81 to 91, decrease. So then one can study that how the population is increasing or decreasing. This is from 1991 census. So this is a decadal growth. So it means, so below negative values and below and above the baseline positive values, then 0 is the central value baseline, and this is the positive values, decadal percentage decadal variation above, and minus negative decadal variation below this. So we draw negative here, positive here, and we can easily say that within this era the population is in a class 5 city in the last 5 years is moving like this. So one can different decades are moving like this. So one can take a decision of how, why it happens. Maybe due to the employment the people are shifting or some other reasons. Broken bar diagram. If the variation between the values is very large, then broken bar diagram we are using it. So smaller values are present in reasonable size, but the large value we are presenting in the form of a broken bar on the top. That is breaking the bars from the top. That's it. So again the bar diagram, but breaking in the top. Now just see the example. Just see example very thoroughly. That how, which example, which diagram we are using it. So different type of staff pattern in a multinational company. So there are 4 vice president, 10 general managers, 20 managers, 2000 clerks, 10,000 skilled worker and 30,000 unskilled worker. Now just see, one value is 4 and last value is 30,000. So it is a big difference. If you want to draw in the form of bar diagram, it is very difficult. So your bar 30,000 will exceed your number of sheets. So come to the a broken bar diagram. So vice president 4, general manager 10, manager 320, clerk 2000, skilled worker 10,000 and unskilled worker 30,000. So from the company backward, so we are make a bar, break this bar. So return the value here. So break this bar, little bit above, because this value is bigger than this. So this value is bigger than this, so this bar has to be bigger than that. So here one can easily understand that what is the staff pattern of this particular company. And next is Pareto diagram. It is a very special diagram. I will show, if time permits, in future classes, that how it can be used very effectively for taking a decisions. So here in this chart, here the category is shown in descending order of the frequency, and we draw a separate curve for the cumulative frequencies. This is a difference. So how this subtotal change the each additional category, so that gives another dimension of our data. Let's see how it is being prepared. Now in one country, in the houses, the people are using different type of heating methods, and number of houses 305, they are using electric method for heating their house. 1121 houses, they are using hot air, and 302 houses are using hot water or steam for keeping their house hot. So first of all, we prepare the cumulative frequency, because on that basis we have to draw a curve also. So then we follow the relative frequency. Relative frequency is nothing but frequency divided by total frequency multiplied by 100. So this value is, how do you obtain it? What is the frequency? 305. 305 divided by 1728 and multiply by 100, it comes to 17.65. So this value is 1121 divided by 1728 multiply by 100, 64.87, and similarly 17.4785. So similarly we are also computing cumulative frequency of relative frequency, that we use for the plotting purposes. So just see. So these are the values: hot air, electric, and hot water, steam. So you see 1100 something houses are there, that we are presenting it. And here the frequency distribution we have drawn it. So it conveys that every additional values, how the value changes. So it conveys that hot air method is the most popular method used by this locality for keeping their home temperature under control. Now another problem has come, the age wise, that is the people are buying the property. So the time of buying the property, what was their age? Now housing people can ask this question, that is I want to sell my properties, so which age group I should give more attention? So age group 15 to 20, they purchase 40 properties, 25 to 35 they purchase 340 properties, 35 to 45 they purchase 500 properties, 45 to 55 they purchase 398 properties, like this. So 1728 number of properties are being sold to this different age group. So you are computing the relative frequency formula. We also know that is frequency divided by cumulative frequency multiplied by 100. Then we draw cumulative relative frequency. So we are presenting in this way. So then Pareto curve, you have to take care of that highest value is to be presented first. So highest value is 35 to 45. So 35 to 45 we are presenting. Then next value is what? 45 to 55. So that is 398 is being presented. Just see, there is a difference between Pareto chart and other charts. All these things are also available in your Excel sheet. Don't worry about that. So similarly, 25 to 35 is the next one, 55 to 65 next one, and like this is where we're doing it. And accordingly, the relative frequency we are presenting in this format. So it means now the company can focus. My first priority should be age group of 35 to 45, and next priority should be of the age group of 45 to 55, and the next priority should be 25 to 35 age group. So accordingly the company can take a decision that on which age group they should focus more for selling their property. That's what the Pareto chart is the best one, but it is always be presenting in the from the highest value to the lowest value. Now pyramid, this we are normally we are using it for the purpose of presenting the population data of different age group. So in this method, the bars we presented horizontally along a vertical line. In case of male and female population, so the population of different age group, in left direction of the vertical line of the bar proportional to the value of male population drawn. In the right direction, the bar proportional to female population is drawn with respect to age group. So these are age group are given 0 to 14, 36.5, 35.9, 15 to 59, 57.9 and 57.8, 60 to plus 5.7 and 6.3. So in a pyramid, we just have a baseline, middle with 0, then different age groups we are putting it. So like 0 to 14, this bar we have prepared. This is for male and this is for female. From 15 to 59, this bar we have prepared. For 60 plus, this bar we have prepared on this. This is our this baseline. One baseline is this and one baseline is this. So presenting this way. So please don't say either I am biased or unbiased. Males and females. Female right side, males left side. I think that in Hinduism, after married, females are always on the right side and they are always right. So that's where maybe that concept was there in preparing preparing the age pyramids. It is a joke. I don't know. It is right or wrong. It is up to you to decide. Now coming to two-dimensional diagram. In one-dimensional diagram, only height of bar is proportional to the value. But in two-dimensional bar diagram, we are taking height and width, which are representing the value. So this is called area or surface diagram. Why we require two-dimensional bar diagram? Where the one-dimensional diagram fails, and where you can say values are so different among them. So difficult to present in the form of one-dimensional bar diagram. So some of the popular two-dimensional diagrams are rectangles, square, circles, and pie diagram. Rectangle, it is constructed on the basis of area. That is area of a rectangle, that is product of height and width of the bar. So the area of a rectangle presented, first of all, height and width of the bar is being proportional to that value. So value are proportional to the area of the bar. Mind it, the value which you are going to present in the form of height and width of the bar. So rest of the principle are exactly same of the bar diagram. So normally we are presenting the square bar diagram. So here the ratio we used to take, the variation in the values or variation in the frequency, if it is the ratio of 1:100, then we present the square bar diagram, square diagram. So square diagram, it will reduce in the ratio of 1:10. So our presentation becomes more attractive. So first of all, for constructing the square diagram, we take the square root of all the possible values. It is easy. In rectangle it is difficult, but in rectangle mostly we use square bar diagram, because we find out the square root and easily we draw a square on that basis. So divide all the square root by minimum square roots of the value and draw squares in appropriate scale with size proportional to these obtained value. So first of all we obtain all the square roots, then all the square roots are divided by the minimum square root values. Let's see how it is to be done. Now density per square kilometer in different countries. Bangladesh 860 is our brother, so naturally they have the high density. Japan 329, oh god, India 254, so Bangladesh is higher than us. China 117 and United States 26. So density per square kilometer is this much. So 26 and 860 we have to compare it. So what we do? Country Bangladesh, Japan, India, China, USA. Density 860, 329, 254, 170, 26. Find out the square root. Square root is 860, 29.32, 329 is 18.13, 254 is 15.94, 170 is 10.82, and 26 is 5.1. So what we have to do now, the 5.1 is the minimum value. From this minimum value, divide all these values. All these values divide by 5.1. So 5.1 divided by 5.1, 1. 10.82 divided by 5.1, 2.12. 15.94 divided by 5.1, 3.12. 18.13 divided by 5.1, 3.55. 29.32 divided by 5.1, 5.75. So this is a source, United Nations World Population Prospectus 1985. So just see, on this basis, now this is our square size. On this basis, this is a square we will draw. So 1 centimeter, now this is 2.12 centimeter, this 3.12 centimeter, 3.55 centimeter, and 5.75 centimeter. So density per square kilometer, our scale is 1 square centimeter present 26 persons. Just see, it present approximately 26%. 1 centimeter present 26%. So this is 126. So the area square centimeter give us how much person are there. So do you not feel this is a much better presentation of our data? Similarly to circle diagram. So circle diagram, it is a little bit one step further. We draw in form of a circle. In this case, the area of circle is proportional to its value. So we have to draw the radius of that. So value, we have to find out the radius. So r is given by, r square is given by value by 7 divided by 22. So draw circle, same method which we have done in the square. I will not recommend you go for the circle. It is very rarely we are using it, depending upon which type of value we are going to present. What is the attribute we are going to present? For that case we are using it. Otherwise you can also try the circle diagram, pie or circular diagram. This is the more important. Mostly we are using in planning. So it is nothing but we are presenting in the form of slices or section. A big circular diagram, here we are draw the pie of that. So it look like the slices which you are cutting out from a circle. So that's why its name is pie diagram. For constructing a pie diagram, the angle of each component is calculated, degree of component value divided by total value multiplied by 360 degree. We know the circle is 360 degree. So let's see how it is being calculated. So first of all, draw a circle of a reasonable radius. There is no you can say any thought of the radius. It is up to you that what should be the size of the circle which you are going to show it. Now draw a horizontal radius which you can declare as a baseline. So from this baseline you draw another line with a degree of components which we have just calculated. So one line with a degree of component, then on that basis this line becomes again baseline, draw another component. Then again from second line will become baseline, then draw another line. So continuously you go on doing this, and if you want to give a color, you want to give a shade, it is up to you. So examples are traffic composition of cordon point number 5, car, gypsy, jeep, taxi, etc., number of vehicles. We have calculated for this degree already for this according to that formula coming 360 degree. Or we can also present number of components, percentage of component we have drawn it, that is 100, it is up to us. Either you give percentage format or you give values of that. So here we are going to percentage format. You can also take a percentage and you can also take a degree. Any of things you will present it. So it is better that if I take a presentation percentage value, so because the people will able to understand very easily in percentage. Otherwise if I have to write in the form of degree, so it is difficult for me to quantify. That's what we are using the percentages. So total values, take the percentages, and on this basis we are drawing a baseline, and the baseline we draw the one curve, second curve, sir, the third pie, the fourth pie, like this. So here we are dividing the whole vehicle population on that quadrant point number 5 like this. So I can easily say that 52% scooter, 11% car, jeep, 8% others. So in place of presenting the degree wise percentage makes our job more easy in convincing the people. You can also put your pie diagram like this. So it is your choice, either a complete circle or divided circles, divided pies. Now coming to three-dimensional diagram. Now three-dimensional diagram is we are using in place of two-dimensional diagram where data is very big. So in this case, height, length and width is a proportional to the magnitude, is proportional to the frequency. So here we are talking of three types of diagram, cube, sphere, block or cylinder type. Block we are less using it, but cube, sphere, block or cylinder, any one of them is. So these type of diagrams which we are using it. Now cube diagram, now what is the benefit of cube diagram? That is the smallest value and the largest value. If it is the ratio of 1:1000, then cube diagram very easily presented or condense the data in the form of 1:10 format. That is the beauty of this. Let's see, that is how the data is reduced from 1:1000 to 1:10. And for a cube diagram, first of all we have to compute the cube root, and the cube root is nothing but anti-log 1/3 multiplied by log a to the base 10. And now select the minimum cube root value and divide all the other cube root values with this minimum value, and then construct the cube of size equivalent to these values. Nowadays by the your Excel or by your mobile phone you can calculate cube root very easily, no problem. Over time we have to see the log table etc. Now rural merit population which are classified on the basis of 1971. Born in place of enumeration, rural merit population 1917. Born elsewhere in district of enumeration, born in other district of state and born in another state. So this is the birthplace migration data of 1971. So we have computed the cube root from 192709 57.89, 18167 26.30, 4879 16.94, 2284 13.15. Now this 13.15 is the smallest value. So divide all this value by 13.15. So it is 1, 1.29 is 2 and 4.396 approximately 4. So this is our size of our cube. So this is our 1 centimeter or 1 inch, you can, your choice. So birthplace, born in place of enumeration 4.4 we have drawn cube. Born elsewhere in district of enumeration like this. 1.29 born in other district of state like this. Born in other state like this. So you can draw a type of cube. Now this cube telling us everything. That is, what is the difference between this and this. So otherwise it is very difficult to compare these four values. Now pictograms. Although I am not going to discuss, it, the more or less the same thing, which you can draw it from yourself. In pictograms, data is presented using pictures related to phenomena. It is very attractive way of presentation. The presentation, the number and the size of picture are proportional to values. How? Now number of TV sets produced per month by a company last 5 years. In 1990 500, then 1991 650, 1992 800 and 1994 1100 TV set they have produced. So presenting in the form of this, one TV set, this is the one TV set, 100 is equal to 100 TV sets. So 1991 90, so I can draw it a half, so I can immediately conclude that this is value is less. So now this pictograms, immediately the traction will be there that here I am showing the something related to TV. So number of TV, then I will read the heading, okay, number of TVs sold in different years. So this is the job of pictograms, to present the data in much better way. Cartograms. So cartogram normally we are using for presenting the regional or geographical based data or facts. So this is done either through map or with the different shades or colors. So it is a partial shades of color, we can present it. Let's take the example of rainfall of India, rainfall map of India. So we are doing the different color with the different shades. The rainfall in centimeter, 0, 20, 20 to 40, 40 to 60, 60 to 100 and above 400. So this is the area when the maximum rain is there. So this area the next one, and these are the area where the less rains are there. So this present everything in cartograms. This is one of the best way of presenting our data, and people will understand very easily what you are presenting, and one can conclude that where that rainfall is more. Lakshadweep is a very heavily rain. Now come to the next part, graphic presentation. Tabular presentation we are done, we are diagrammatical presentation we are done. Now we are coming to the graphical presentation. So again, what are the principle? The graph paper, either it is should be in the form of inches or centimeter, it is up to you. So but one should take care of that. Graph should be neat and clean. It should be very simple. They should not have any complications. Each graph should have a graph number, graph title, footnote and source note, as we had done it in our previous tabular presentation. We had discussed that. So in graphical presentation also we should give number, title, footnote and source note. Now coming to scale and framework. The axis should be drawn in such a way that it is easy to accommodate the whole data in a one page. Normally we are putting the independent variable on x-axis and dependent variable on y-axis. But for time series data, the time we are taking on x-axis and variable we are taking on y-axis. These are certain thumb rule which you are taking it. So approximate scale for both the axes should be chosen or should be taken so that the figures are visibly clear. We can understand what you are showing it. And for relative data, we are going to use ratio scale or log scale instead of our arithmetic scale. Now time is not permitting. Ratio scale and log scale are highly useful, but I am little bit scared that you people have used it or not. It is very important because it is not the part of our today discussion. If the values are quite far away, then false baseline we can use it for better presentation. Then index. Each graph must have an index describing different types of lines. The lines may be the form of dotted lines, broken line, dash dot, etc. etc. You can draw different type of lines also. Graph of two type data. Graph of frequency distribution, graphs of time series data. And probably we are not going to discuss today graph of time series data. That is again another subject, time series. And actually in your 8 hours we can't discuss even the time series. Now frequency distribution, here the data is of the 4 categories. It is a histogram, frequency polygon, frequency curves, OGIFs or cumulative frequency curves. What is histogram? Histogram we are using it for presenting continuous frequency distribution data. So we are constructed on the vertical adjacent rectangles of the height proportional to the frequency on a baseline on the x-axis. We put a type of a bar. It is a vertical, but they are joining with each other. Each bar is joining with each other with equal width to class interval of those frequencies. In case of group or discrete frequency distribution, first of all we have to convert it into continuous frequency distribution, then we can draw it. So histogram has to be drawn on continuous frequency distribution, cannot be drawn for discrete frequency distribution or group frequency distribution. Let's see. Number of villages away from the state capital. 9 to 9.5 kilometers, 40 villages. 9.5 kilometers to 10 kilometers, 70 villages. From 10 to 1050 kilometers, 10.5 kilometers, 60 villages, and so on. So in the class interval, 0 to 9 we don't have any data. So all are of the equal width. Just see all of the equal widths. So this is the data which we are presenting. How many number of villages and distance on x-axis and number of villages on y-axis. I should have written here number of villages. This is my mistake. I have not written. It should be written number of villages. Now if it is an unequal class width, up to now we have discussed the equal class width. If it is an unequal class width, that is number of household having their daily earnings. There is 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 40, 60 to 80. So just see, here the class interval is 5, 5, 5, 5. Here the class interval is 10, here the class interval is 20. So the frequency is being given, size of class interval is there. So first of all we have to create adjustment factor. This adjustment factor is equal to magnitude of the class divided by lower class interval. Magnitude is the frequency. Frequency divided by the class interval. So height of a rectangle is 110 by 1, 110, 150 by 1, 150, 90 by 1, 90, 80 by 1, 80, 100 by 2, 50, 120 by 4, 30, 240 by 4, 60. So this is the height of the table as comment. And mind it, our class interval, this will play an important role when we draw the histograms. Just see. So wages we are giving and the values we are giving. So these are equal class intervals is being there. And here just see 30 to 40, 50, 40 to 60, 30 and 60 to 80, 60. So that's how we have an unequal class width interval. We can draw histogram like this. Now coming to frequency polygon. Now frequency polygon we use to present discrete or grouped and continuous frequency distribution. So we can present discrete as well as group. So in this type, it is a type of a line diagram in which midpoint of class interval or value of a discrete variables are plotted along x-axis, again corresponding frequency on y-axis. So on x-axis we are putting the value of midpoint of the class interval or the value of discrete variable, and y-axis we are putting up the frequency. Then this points, this plotted points we are joining by straight line. So this polygon is supposed to close one. So the first plotted point is joined with the midpoint of the dummy class preceding to the first class. Mind it, the first plotted point joined with the midpoint of dummy class preceding the first class, at the last point with the midpoint of the dummy class succeeding the last class. So it can also be drawn from the histogram, you can also draw it. So in this case, midpoint of top of the rectangle are joined together by straight lines. So either use directly from the data, if you have drawn the histogram, you can also draw from the histogram. Let's see how. Milk produced in liters by cows or in buffaloes in a village. Total production is given in liters, 600 to 700 liters, number of cows and number of buffaloes. And total is given now 64 liters, 132 liters, 350, 30, 250 liters. So now I have to draw that frequency polygon. Just see. Number of cows 61 liters, 71 liters, 81 liters, 91 liters. So these are cows we are presenting it dot 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 like this. Number of buffaloes we are taking it and total is presented. So these are the values. These are single discrete values which are taking it. So here at the middle point of this we have taken it. From here 700 to 800 we have taken, and correspondingly we draw the frequency polygon. So we can see how it is. Now coming to the frequency curves. So frequency curve we can draw it the same way as a frequency polygon, with the difference that now points are joined by smooth or free end curve. So it is also necessary that curve should pass through all points. So in place of straight line, we are drawing the curves. That we are going to do it. Now number of token purchased by guest arriving in a function, number of token 6, 7, 700, and number of guest is this much. So token and values, this draw a simple curve, number of guest. like this. So that we can draw frequency curve like this. Now type of frequency curves. There are different type of frequency curve: symmetrical curve, skewed curves, J-shaped curve, U-shaped curve, bimodal curve, trimodal curve, or sigmoid curve. These are the different type of curves which we are going to now see it. How this type of curves are being shown or being drawn. Now this type of curve is known as symmetrical curve. Just see, that is a equal number of this values are being presented. So along with this we can present it in the form of cylindrical points. Next is positively skewed curves. So this curve is being moving like this. More concentrated highest value this, and here it is flatter here. Positively skewed curve. Then this is negatively skewed curve. That is heavily density here. High values are like this. This J-shaped curve, J-shape, inverted J-shaped curve. You can draw it like this. Then U-shaped curve. You can draw the symmetrical like this. So these are the type of curve we have seen it today, and these are the we have seen different types of presentation of the graphical values of the presentation. Bimodal curves. This curve shows this curve having two peaks. One peak is this, two peak is there. I pray to God that in a corona we should not get the third mode also. I wish that the two modes are sufficient to present corona sufferers in India maximum, which I got it. So this is a bimodal curve. You can have trimodal curves. So there are three maximum values which are presenting up and down. So that's why the different type of curves are we can present it in the different manner. That's the beauty of this. Sigmoid curve like this. Each curve is having different significance. Each curve is having a different values that we'll see it when we are drawing in the real life data. Then you will come to know what type of data it is. Now coming to ogive or cumulative frequency curves, that we are going to do it now. From the name it is very clear we have done the cumulative frequency distribution. So it is nothing but the cumulative frequency we are presenting the form of a cumulative frequency curves. So points are plotted with respect to boundaries of the class interval instead of midpoint of the class interval. That is the important. Not the midpoint of the class interval, only the boundary of the class interval we are using it. It is two type, less than ogives and more than ogives that we are using. In less than ogives, the points are plotted using less than cumulative frequency against the upper class boundaries of class intervals. So whatsoever the upper class intervals boundaries are there, we are meeting those points. While in both the ogive, both the cumulative frequency is used against the lower class boundaries of the class intervals. So this is the difference between the both the curves. So the plotted curves are joined with a smooth freehand curve. So it gives you very good presentations. Class interval 5 to 10, 10 to 15, 15 to 20, 30 to 25 frequencies, less than cumulative frequencies and more than cumulative frequency. We already know how we to calculate it. So when we draw it, so it is. So either you draw from your histogram or draw directly from this. So this is the curve. This is the median that shows us the values. So less than and more than ogives, which we are able to present it. So that's how we are able to present diagrammatic form, graphical form, tabular form of presenting the data. I hope that now you can present your field collected data in much better way and use these techniques so that you can convince the jury members as well as to the people to whom you are presenting your work. Okay, thank you very much. Thanks a lot to listening to me.